In this lesson, we're going to place extra instances along our sidewalks for street elements, like benches, lampposts, and trees. But unlike with our sidewalks, where we handled this using two different node groups, one for the outside palm tree and another for the inside shoulder here, we can do everything in just one node group. So we can pull our road curves directly from here, before we split them. I'll drop in a reroute node to branch it out and move it down. Another reroute node, just like we've been doing. Let's move another reroute node here. Press Ctrl G to wrap this into a new node group. Rename it. The output will be instances. The input will be our code row. Let's move forward. First, we'll separate each edge into its own spline, just like we did earlier with the crosswalks. That helped fix the issue with crosswalks not connecting properly. We'll also rename this node group to street instances. Let's move this over. I'll make it a bit wider. Then I'll link this to our join geometry. To split them into individual splines, we first need to convert to a mesh. So, CTM convert to mesh. Then we'll add the duplicate elements node. We'll duplicate edges. Repeat this. Check the spreadsheet again. When muted, we see 25 edges and 25 vertices. When unmuted, we get 50 vertices. Each edge is now a separate mesh island. I'll clear the view. Now we'll convert back to a curve. MTC mesh to curve. Now each one is its own spline. We're doing this so we can use the trim curve. Note this lets us trim the start and end of each curve, avoiding instances on the corners. We don't need trees growing where sidewalks or crossings are. We just want instance is on the straight parts of the sidewalk. How will we trim them? It needs to be done by length, like we did before. Let's add our scoring again. We subtract, and again. We subtract a value that connects into the start and into the end. We could make this a parameter, of course. But instead, I'll just insert a single value that connects into both the subtract node and the start input. Now, by scrolling this number up or down, I can set how far we trim from each edge. So for now, I'll enter 10. Of course, this is something you could expose outside the node group and adjust independently for each element. I won't do that here, but it could be your homework before moving on to the next chapter. Now that we've trimmed the curves, let's convert them to points so we can place instances. So use curve to points. I'll set it to length. Now if we check these points, there are a lot, since the length is 0.1. That means we're generating a point every 10 centimeters. Now, how far apart should the points be? Let's set it to 20 for now. We can change it later if needed. Now let's bring in our benches. We'll instance them on points. Okay, drop this into the instance as input of the benches and connect rotation to rotation. Just like before, they're not oriented right. So we rotate them correctly using rotate instances. We'll rotate them up along the x-axis and around the y-axis. Now we have a small problem. All our curves face the same way, which is what we wanted at first when we unified the curve tangents. But we don't want benches on the inner curves pointing into the city blocks. We want benches pointing outward on both sides. So what we can do is go back to our curve road and reverse it. That flips all instances, since the rotation depends on curve direction. But we can limit the rotation using a selection. We'll use an attribute we created it at the beginning. It's our outside boolean. So if we connect this into our selection, we now have the benches facing well. They're almost facing the correct direction. We just need to flip the rotation by -90. Now all benches are facing the way we want. We just need to move the instance back. So we shift them by about 2.5. And down. This can be handled procedurally, since depending on the width of our sidewalk, this value might differ. We may want these values to change. I'm not going to handle that right now, but that's something you can try. If you've been following the course, you should now be able to bring in the sidewalk width as a parameter and use it in this translation. So now that we've done benches, I'll wrap all of this up. Let's scale these nodes down a bit. I'm going to frame all of these nodes and call it instance benches. Then I'll copy the whole group, rename it to instance trees. I'll switch the collection to be the street elements trees collection. Join this together. I'll need a join geometry node to connect these. Now we'll obviously get trees in the same locations as benches. That's not what we want. So we'll tweak some values. First, how far we're trimming from the edge, let's adjust that slightly. I'll tweak the benches too. We can also change how frequently the trees appear. So, maybe 15 m. Maybe 14 m. Something like that. Let's also change the translation to offset them. Now we'll do the same thing for the streetlights. I'll copy this whole setup again. Rename the frame to instance streetlights. Then change the collection to streetlight. I want lamppost. Let's plug this in. And again, we need to change some values so we don't get any overlap. So let's change this to say that a couple of points appear every 8 meters. That's for the lamppost. We'll move it back slightly and push it forward a bit. Recenter these. That looks okay. There we go. So now we've got lampposts, benches, and trees. And really, there's no limit to how many things you could add here. The only thing is to make sure they don't overlap. There are other ways you could do this by instancing ungenerated points, distributing those points, or figuring out how to manage that. We'll come back to that when we get to the hatchback element on top of the buildings. But this is just one way to distribute instances evenly and with good spacing across our sidewalks. Finally, the last thing I want to do is for the lampposts. When we looked at this element way back in Chapter 1, if I enter local view, on this lamppost all the materials had an attribute called lights that was connected to the emission. Now obviously, right now that value is 0 because the attribute doesn't exist. But what I'd like to do is go into my geometry, nodes leave local view, and on the street instances, I'm going to store a named attribute. It will be a boolean and assigned to the instance domain. Since these are instances, we'll name this attribute a light. If I toggle this on or off, it will switch the streetlights, which is going to be very useful. We'll expose this outside of the node group. So I'll grab that switch, input, and rename it to lights. So now we have a lights boolean outside this node group. We'll later add this to our building settings panel in the next chapter. Before we move on, the last thing I want to do, the final lesson of this chapter, is to return to the materials for the road and sidewalks, just to polish these up a little bit and make them look a little better.